Alright, so for my engineering project, I found a fabulous lesson on teachers pay teachers, and I want to give this person all the credit in the world because it's a fantastic lesson. It's Julia Cannon. It's off of the Nerdy Scientist Teachers Pay Teachers store. And then I just added in some tweaks to it, so I'm just going to go through my project. So the NGSS standard, the engineering standard that it follows, is define a simple design problem reflecting a need or a want that includes specified criteria for success and constraints on materials, time, or cost. And you'll see, and we'll go through, and it talks about all the different constraints that there is. The overview of the lesson. In this lesson, students will learn about the engineering design cycle. They will learn about how astronauts must have specifically designed food packages to use in space, and they will go through the engineering design process to design, build, and refine a package that will allow astronauts to eat M&Ms in space. So, let's get started going through my lesson. So for day one, it's kind of like an introduction to the project. They're going to watch a video. It's just about 2 or 3 minutes of some astronauts eating some food in space, and you can see, like, I'm trying to think what they were eating. They were trying to take a bite, and then it was coming out like off their spoon, so they can see how, they don't have gravity up there. And then I'll ask students what they noticed about the meals in space, how eating in space is different. I'll pass out M&Ms. I'll pass out the little packets of M&Ms and tell students that we will look at the rubric before we begin each part, so that way we know exactly what we need to get, or what we need to do to get a 4 in each section. And I'll show you the rubric here. It's pretty, see if I can get it right, pretty self-explanatory. It goes through, and it'll go through it the whole way down, and you can talk about it throughout the whole lesson with your kids. Basically, it says, did you correctly identify the problem and include 3 criteria and 3 constraints? Did you include 2 sketches with pros and cons listed for each? Are all parts of the group's designs are completed and model is completed by the deadline? The students gave feedback to other groups at least twice and makes improvements on their own design. They use nice and neutral words and tone, stays on task, they have a low volume, and they follow directions urgently. So those are, I read the things that they could get a 4 with, and then it goes on to what they can get a 3, 2, and 1. And this is a fantastic rubric. I take no responsibility for it, and I didn't change it at all because it is just such a fantastic rubric. So then I'll show them. I'll order some space ice cream in advance, and I will show it to them and ask them questions. And if there's a question, let's see, there's a page. And students will be given this packet that has lots of pages through it that will take them through the whole lesson. So this is the first one, M&Ms in space, and then it shows regular ice cream, space ice cream. Why do you think space ice cream is designed this way? And so they'll just go through and respond to that question. Then we'll read and discuss the background and your mission. The background just says, astronauts love to have good food in space, but they can't eat it like we do on Earth. Why? There are a few reasons. The main reason is that objects float in space. Food does not stay down on a plate or even on your hand. Another reason is that there is not much room on a spacecraft, so food has to be in a small, light package. Lastly, astronauts have a lot to do, so packages should make eating easy and fast. Then, your mission. Astronauts love M&Ms, but when they open the bag, they fly around everywhere. Engineer design a package that will make eating M&Ms in space easy and fast for astronauts. Your group will have $5 to buy supplies at or from your teacher's store. And this is one of the coolest things because that's a constraint. The cost is a constraint. So then I will show the students the store with materials that they will be able to use for the project. And let me scroll back up. So the materials that they can use are cardstock, tape, and those are half sheets of cardstock. Half sheets of computer paper, Ziploc bag, 4x4 squares of wax paper, and 4x4 squares of aluminum foil. So those are the different materials. And then it shows a page, let's see, where's this page, of the cost for each. Let's see. Yes, here it is. And they'll see this later. Let's see if I can get it right. So those are the costs for each of those. Let's see, where am I at? So then we'll talk about the engineering design process, and I'll explain to students that they're going to be engineers in this project. An engineer is a person who uses science, math, and innovation to find solutions to problems. And then we'll go through, where's the blank one? We'll go through this together so we can really talk about it. It's an engineer and is a person who uses science, math, and innovation, and they'll have to fill that in to find solutions to a problem. When engineers solve problems, they go through the following process, and then we'll go through each. And in the lesson that the Teachers Pay Teachers Lady designed, she didn't really talk about each engineer process in depth, and that's something that I would add in. I would talk about each of these processes more in depth. And students, you see, have to fill in the blank. Sorry, I can't point well. The blank for each one. So identify the problem, and we'll talk about it after they fill it in. So then that will probably be, since I'm going in depth, that will be it for day 1. And then day 2, the first step, it goes through each of the engineering design steps. They'll identify the problem. So I'll instruct students to move into their lab groups and read to students that what they must do, turn a 4 again on their rubric. And I'll tell students that before engineers begin working, they need to first identify the problem that they're going to solve. So then I'll give them, let's see, where's the sheet? I'll give them this sheet. Ooh. So what is the problem? We'll have to write the problem. And then we'll talk about the criteria and the constraints. So I'll describe the criteria are specific outcomes for the project. The more specific you are about what you want to see before you start your design, the better your project will end up. So I'll give one example for criteria to the students, and I'll say, well, the package must be light for space travel. And we talked about this in our background information, so they'll have to write that. Oh, hold on their criteria. And then I'll give students time to brainstorm 2 more specific criteria that their project must meet, and I'll let them kind of work together on this because I know it can be kind of tricky. So examples could be must keep M&Ms from floating away, must be easy and fast to use. And so I'll tell them refer back to your background. Then I'll describe the constraints, and that was on the other side. Our limits to the design of an invention. And I'll give one example of constraints, and I'll give one example for the students. We will not be able to test our package in space when we are done. This will limit how we will know for sure that it will work. So then again, I'll give students time to brainstorm 2 more specific constraints that their project must meet. And some examples will be they have limited material, they only get $5, they have limited time, they have limited tools. So that one should be a little bit easier for them. And then they're finally going to get into their groups, and they're going to brainstorm. So step 3, brainstorm possible solutions. So then I'll have students, I guess they won't get into their groups yet. I'm going to have them individually create sketches of an idea for their package. The team will discuss different ideas and pick the best one to actually build the next day. So then I'll emphasize that brainstorming numerous ideas before building allows for more chances to get an excellent design, and I'll read to students what they must do again to get a 4 on this. And then I'll remind them to make sure they consider their criteria and constraints for their sketch. And then they'll be asked to label the materials that they want to use for their sketch so they'll be ready the next day so they can purchase these materials. And then that is all for day 2. Day 3, they'll determine the pros and cons of brainstorming. So then I'll instruct students to pick the best design from their brainstorms, and then I'll have them, before building, they must create a design plan on this page, and the one I showed you earlier. So they have to put down the quantity of each material that they want, and then they have to add up the total dollars, and I'll help them with this one because they've forgotten money by now. And then they have to draw a sketch again and label the pros and cons for each idea. And then in the design plan, and then I'll let them come get the materials and they can begin building for the rest of the class time. And then day 4, before moving into groups, I'll have them come together as a class and give feedback on each one. I'll hold each design up and say, okay, give feedback to this person. And they'll have another paper they get. where they have to give feedback to each group, so they keep track of, okay, what I'll have things to say for each, and I'll keep track of that on my page, things that they're doing well, things that they can improve on, and then each group has to consider what each other group is saying, and then they have to go back into their plan and redefine their project. And I'll open up the shop if they still have money. I'll open my shop back up and they can get more materials. And then day 5, they'll present their designs to the class, their new and improved designs. And after I'll hold a discussion of what the students have questions over about space and gravity, and most of the students will probably be like, oh, what's it like to live in space? Like, I want to know more. And so then I'm going to give students a QR code to this site. It's ESA for Kids, something like this. I included it in my lesson, the link. And it's about life in space. And I'll have them read through the article with a partner on their iPads, and they can then continue on and read about spacewalks, washing up, going to bed, etc. And then after reading, students will write a paragraph or so about what it's like to live in space. Sorry, I know that was kind of long, but that is the gist of this project. There's a lot to it, but again, it's such an awesome project, and I give so much credit to the Paid Teachers lady who created this. And yes, I did make edits to it, but it's such a fantastic lesson or project. So there it is.